problem statement. Draw the root locus diagram for the system whose open loop transfer function is given by gh of s is equal to k by s plus 10 power n. The first part of the problem is when n is equal to 3. Second part of the problem is when n is equal to 4. So this is the transfer function, open loop transfer function given. For that we need to draw the root locus diagram. But where s plus 10 is the transfer function power n, but n where is the first time it is 3 and second time it is 4. So that means if n is equal to 3, there are 3 poles in the denominator. At the same point s is equal to minus 10. When n is equal to 4, again there are 4 poles at s is equal to minus 10. Now how to draw such kind of problems. Now, so take the first one, n is equal to 3. When n is equal to 3, the open loop transfer function gh of s becomes k divided by s plus 10 power 3. So this is called triple pole. Now write down what are the poles and zeros. You know that number of poles p is equal to 3, number of zeros z is equal to 0 because there are no zeros at all. So your s is equal to minus 10 and minus 10. 3 poles at s is equal to minus 10. Locate these poles and zeros on S plane. S plane is available here. So this is origin. From here you take 10. So when you draw this, you cannot take directly 10 centimeters in a graph. You can take 1 unit as let us say 1 centimeter as a 0.5, 1 centimeter as 0.05, or the reverse is also you can take it. So depending upon the poles locations, we should take the scale properly. So for example, s is equal to 10. S is equal to 10 means you can take 1 centimeter is equal to 2 units. Therefore 1 centimeter is 2 units, another centimeter is 4 units, like that you can take it. If at all if you want 2.5 or 3, depending upon your graph, then you should take the scale properly when you are sketching this on your graph sheet. Root locus diagram always preferable to draw on the graph sheet only. Now, so I am taking there is a pole, not one pole, there are 3 poles. S is equal to 10. So S is equal to 10, there are 3 poles, 1, 2, 3. It's a triple pole. Next, what will be the second step? The second step is identify the root locus area. Now, if you identify the root locus area, it's very clear. The root locus can exist from s is equal to minus 10 to minus infinity. So this is your root locus area, minus 10 to minus infinity. The third is we need to get the information about the asymptote. So we know that number of poles p is equal to 3, z is equal to 0, asymptotes a is equal to 3. Then what will be the centroid? Sigma poles minus sigma zeros divided by p minus z. So minus 10 divided by 3 will be minus 10 only. So centroid is minus 10. Therefore all my poles are here, and there itself I have centroid s is equal to minus 10, that is c is equal to minus 10 we taking. Then there are 3 asymptotes, theta 1, theta 2, theta 3. Directly we can write down those asymptotic angles. Theta 1 is minus 60, theta 2 is minus 180, theta 3 is minus 300. Therefore from centroid you draw first one A1 with 60 degrees, second is towards the left direction towards minus infinity, that is A2, and third is in a downward direction, that is A3 with 300 angle, minus 300 angle. So all 3 asymptotes, centroid is available, pole locations also are available. Next is we need to calculate the breakpoints, look at whether the breakpoint possibility is there or not. Now there are 3 poles at this point. Whenever you have 3 poles at this point, look at that, the other side, that means the right hand side you don't have root locus area, left hand side root locus area, but there are 3 poles. Means one root locus branch will start here, it can go towards the left direction because we have one asymptote in minus 180 degrees. What about the other 2 poles? Okay, so using those other 2 poles information, we can say that there can be one breakpoint. Okay, and directly you can say that breakpoint is going to be s is equal to minus 10 only. Let us calculate and see whether this is correct or not. So write down characteristic equation 1 plus GH is equal to 0. Then from that you write k is equal to f of s function. Then if you write k is equal to minus s plus 10 whole cube, then if you differentiate, you know how to differentiate that. So if you write dk by ds is equal to 0, then you will be getting equation as s cube plus 20s plus 100 is equal to 0. The roots are s is equal to minus 10 minus 10. So s is equal to minus 10 is the pole location. So pole location itself is a root locus area. So whenever you have pole location, that is also root locus area point. So this point is the valid breakpoint. You can take that point as the breakpoint. So coming to the next step, we have imaginary crossover point. So look at whether there is a possibility of imaginary crossover point or not. Yes, there is a possibility because there are two asymptotes which are moving from LHS to RHS, means right half of the S plane to, from left half of the S plane to right half of the S plane. Therefore, your root locus branch also will move from left half of the S plane to right half of the S plane. Let us do the calculations how to do it. So S plus 1 plus GH is equal to 0. So 1 plus k by s plus 10 whole cube is equal to 0. So that we will be getting equation as s cube plus 30s square plus 300s plus 1000 plus k is equal to 0. This is the characteristic equation. So it is s cube. Therefore, I need to have 4 rows in Routh's array: s cube, s square, s power 1, s power 0. So you just fill the first two columns from the characteristic equation, 1, and we have 30, and we have 300, 1000 plus k. Then what will be the calculation of s power 1? So that is you have a 330 here, 30 into 300 minus we have 1000 plus k into 100 divided by, so we have 30, and the other one is 0, and this will be carry forward here. So this is going to be 1000 plus k. And we know that in Routh's array, if you want to make one row 0, always take s power 1 or s power 3 rows. So s power 1 row I should take. So when I take s power 1 row, and this part is equal to 0. When you make this part is equal to 0, you will be getting the k value as 8000. So 8000 is the k value. At this k value of 8000, you will have one row completely 0 elements, and we should take the just above row coefficients to form the auxiliary equation. And if you write the auxiliary equation, that is going to be 30s square plus 1000 plus k. Therefore 1000 plus 8000, that is going to be 9000. Then if you solve this equation, auxiliary equation, you will be getting the imaginary crossover point. So that imaginary crossover point s is equal to plus or minus j 17.32. So locate that 17 plus j 17.32 minus j 17.32. So whenever the root locus is moving from left of the S plane to right of the S plane, it has to cross the imaginary axis at that point only. Next, again there are no complex poles, complex zeros, therefore no angle of departure, no angle of arrival. So complete information is available. In the next step, you are going to draw what is the root locus diagram for the given GH of s, k by s plus 10 whole cube. Now, so information is already available. What are the things we have seen? There are 3 poles at s is equal to minus 10. There itself I have a centroid s is equal to minus 10, and there itself there is a breakpoint s is equal to minus 10. Centroid, breakpoint and pole location, 3 are same only. Now I have 3 asymptotes A1, A2, A3. Therefore, I can easily say these 3 poles just to follow their asymptotes, that's it. Because, so 2 poles are here, that is a breakpoint. So one is directly going along with the your asymptote, because my cross point is 17.32, your asymptote is also crossing the same point, plus j 17.32. Therefore, it follows the A1. Similarly, it follows minus 180 degrees A2, one of the root locus branch. The other one is going downward direction, which follows A3 with the same crossing the imaginary axis at minus j 17.32. So this is my complete root locus diagram, and from that we can this system is conditionally stable, and system is stable for k ranges 0 to 8000, and after that k becomes unstable. And what the other conclusion is, whenever you have triple poles like this, or triple pole at one particular point, your root locus diagram, just to follow the asymptotes or over the asymptotes, we will have the root locus diagram.